and you're going to go over some things, but if we can hold off, some of that may be discussed in this presentation. So just for everyone's information, this meeting is being recorded, this webinar. Today we're going to be talking about the use of 3D radar and GPR products. Kent Martin is joining us today from 3D Radar. He's got a really robust line of GPR devices with his 3D Radar company, and we've been working with Kent for a while now, offering Spectra Precision products. And for those that don't know, Spectra Precision is a Trimble company. So Trimble and Spectra, under the same banner. But Spectra in this particular case fills a really great niche with a couple of their devices, and the one we're going to be focused on today is going to be the SP60. But we're also going to be talking about Kent's 3D radar solutions and some of the GPR work that his customers are doing with that. So we'd like to go ahead and let Kent share his screen. He's got a presentation. We're gonna look over some of his stuff, and then we're also going to talk about Spectra as well. So Kent, if you want to go ahead.
Sure. Thank you so much. Let me just get this. Can you guys see my screen? Perfect. I think I can see it. Thank you very much, guys. My name is Kent Martin. I'm the Global Marketing Manager for 3D Radar, and just put together kind of a short presentation about what we're doing and how our customers are really requiring a good solution for positioning as a general rule inside of their applications, and also how we've really kind of started working with Duncan-Parnell and Spectra, and the SP60 has kind of become our go-to immediate recommendation for our clients. 3D Radar is a Norwegian company. We were founded by a professor at University of Trondheim about 20 years ago. We just actually celebrated last month our 20th anniversary, and we've got offices around the world, and we sell around the world. I basically run the US for us, and then I do the marketing for the entire globe. I'm just going to be kind of going through pretty quickly here, so if anyone has any questions, feel free. Pretty informal, so just shout out any questions as we go through, or save them up to the end, whatever you guys like. So ground penetrating radar is a non-destructive testing mechanism that allows you to basically go over the ground and see what's beneath it. And essentially it's firing electromagnetic pulse down, just like a radar, and then measuring the response from the subsurface as it comes back up again. And that's really important for things like roads and bridges, airports, tunnels, dams, levees, railroad, airports, all of those types of things. Utility mapping is obviously one of our big spots also. Anything that you really want to see what's going on below the ground without having to actually take a core or dig up the ground and potentially hit something that you didn't know was there. So basically, what happens with this? Without getting too much into the technical expertise, we fire down at a certain set of frequencies, and then you measure the response as it comes back up again. All of our secret sauce is in two parts, really, that differentiates us from other different types of ground penetrating radar technologies. And what that does is there's a general rule where the higher the frequency, the better resolution but less penetration you get. The lower the frequency, better depth penetration, but you have less resolution. So you've got to kind of match what frequency you're going to shoot to the subsurface with your target and how deep you think it is and what your soil conditions are, ground conditions. So we kind of get around that by every time we fire, every single one of our antennas will shoot through 150 megahertz all the way up to 3 gigahertz and all the intervening frequencies. So we don't have to choose one. We use all of that frequency response every time we take a sample from the subsurface. And the second part of that is essentially all of our antennas are actually arrays, which means it's got multiple transmitter and receiver pairs running through the width of the antenna. So you have a really dense collection and really a true three-dimensional cube of data, and it involves the entire frequency response. So you have something that is essentially the best resolution for any depth point. And it gives you a three-dimensional cube that when you look at it, you can really tell it looks like what it's supposed to look like. So this is essentially what our examiner software looks like. Obviously, it's a GIF where it's moving through it. But as you can see where the cross hair is moving through, it actually moves across all three screens. So your main screen on the side is your side view on the top part. The bottom is actually a ground up view. So it's like you're peeling away the layers of the earth, and you're kind of seeing things like peeling through an onion. The right-hand side is your actually width of the antenna. So that's moving through all the different channels on the width of the antenna. And that gives you the ability to work with your data in true three dimensionals. So what does this data look like? And then we'll go into some collection on different types of stuff, and why is it so important for us to have accurate positioning, and why all of our clients, that's really one of the big things that they require, because you can see stuff, but if number one, you can't place it, then obviously it doesn't help you very much. So this is an example from Test Track, actually, in Caltrans, one of our customers, and they have a bunch of different features here, which are really kind of interesting. So you can see delamination, you can see thermal segregation. The thermal segregation is actually a really interesting part, and this is showing kind of how sensitive our instrument really is. And what happened is, when we first saw this, the delamination was pretty easy to figure out. So this is a top-down view, probably about 6 inches down through the asphalt. And when we saw these, what's marked as thermal segregation, we didn't know what those were. So we actually had to ask one of our asphalt customers, and what is that? It's obviously regular. It's the same interval in between. And what it is the contractor did not keep the essentially the top of the pour, the bottom of the pour, the same temperature. So when that was the end of the dump truck putting the asphalt down, it was actually a different temperature than it was supposed to be. So you end up having this regular bit. That's one dump truck load full of asphalt coming down on each part. And that eventually will cause things like stripping and delamination inside of the asphalt structures themselves. And that's one great thing about this as a technology, is you can actually kind of go down through the depth and things look like you would think they look like. You can see bottom of the asphalt, you can see all the way through the road structure itself, and find things like on the right-hand side, sorry for the sensor, the R is off, those were actually sensors that were inputted into the asphalt. Clearly see those. And again, things look like you would figure they would see. Different layers, you can see the bottom of the pavement, you can see where the depth of the different layers are. So how thick is each layer, asphalt, subbase, all that kind of stuff. And you can map those things out and really be able to tell in 3 dimensions what is going on inside of that structure. And obviously defects are a big thing. And then mapping them, throwing them out there. So just kind of giving you some other ideas. Another one of our customers is a group called Cat Surveys, and they started out as utility mapping specialists and then moved really into aviation, and they own the sole source basically for all GPR work for Gatwick and Heathrow airports. And I don't remember which this is, it's one of their airports, but airports are really interesting because it combines a lot of different kind of normally disparate applications. So you've got asphalt, you've got concrete, you've got pavement, you've got bridges, and obviously all of it is filled with utilities. So when they're going through, they've got to give a really complete analysis of what's going on inside of that structure. Every utility line, all of the delamination in the asphalt or concrete, where your dowel bars are, how's your reinforcement, how's your rebar look, those are really large projects. So they've got, I think they're up to like 1,000 surveys a year now. They're up to, I think 1 day of field work is going to show less than 1 day of analysis to a report. So these guys really are industrial. They're out there every single day. And obviously, particularly on things like this, If you're off by a couple of feet, you're not going to necessarily know when you take a core how that structure is. So if you're trying to core where you see some of the delamination or problems in the asphalt, if you're off on your core or off on your positioning inside of the GPR data, you're not going to notice and be able to confirm that that problem exists. Also, if you're off on the utility line, let's say it's worse, a gas line, and you're digging in the wrong spot because you don't understand, you didn't design it through because your positioning was bad inside of your GPR data, that obviously becomes a huge problem. So when people go out and do all of these types of jobs, again, each one of these antennas that you're seeing is an array. So it's got a bunch of channels spaced 3 inches apart, each one of them getting the entire frequency response from the subsurface. So one thing you'll see in common with all of these vehicle platforms, and in a second, some of the even the pushcart platforms, they all have a GPS external system that mates with our system, and that gives you the really high level of accuracy you need for the positioning itself. So what we end up doing is we've actually got an internal GPS system inside of every antenna, but it's roughly analogous to your phone. So it's 9 meters potentially accuracy. Obviously, that's not good enough for any kind of real survey work. But what we do is we use that as a really precise timer clock. And we take the external GPS system and we take the timestamp on a NEMA stream and we match that to our internal. And we also have a DMI that shows you your trigger spacing, how many samples do you want to take per whatever unit. And that's how we position the data. So every bit of our GPR data is geo-referenced. And it is crucial that whatever that external GPS system works well with our system and then provides for our customers less accurate, relatively speaking, in terms of the accuracy scale. If you're, say, doing asphalt, you don't kind of care if you're 4 inches off or 3 inches off. But if you're doing utility mapping or, say, concrete dam inspections, you need very high accuracy and you have to be right on. So one of the great things is we got introduced to Duncan-Parnell, and Russell, I believe, it was actually one of our customers who had approached you guys. And for the first time, I ever got a phone call back from a GPS supplier saying, hey, we want to help your customer get the right thing. Can you go through your system with us? And so we can understand it better and be able to recommend the right product. And I just thought that was amazing. Russell and I have traded tons of phone calls over since the time intervening, and I've tried to introduce him basically to every single one of our customers that requires an external GPS system. Some of our groups we sell to Department of Transportation's, engineering firms, small engineering firms that just do SU. But any of them that don't have a system in place that they're just going to plug in and use, then I immediately say, hey, I'm from New York, so I got a guy. I make sure that they get to know Russell, and he can use his expertise and what has really basically become a broad reference to the Spectra line, and that gives them the ability to match their positioning needs correctly to the product. And it's also a wide budgetary group, and they can also grow into something too. So many of our, particularly the engineering firms, start out doing one particular application, say it's utility mapping, and then they grow into pavement and bridges and everything else, or they kind of continue around the circle from one of the other areas. And different areas and applications have different requirements for precision. And what we can do is essentially offer them a solution that has the requirements for our system. Specifically, we still use a cabled solution. So it's got to have a cable that goes into our geoscope, which is our radar unit. It's got to have the right accuracy. It's got to have a timestamp NEMA stream that is able to do the correct baud rate and comport and all that kind of stuff. And what Duncan-Parnell does for us is able to put the customer into the correct product for what their needs are, and then configure that for them. So when it arrives, it's a plug and play into our system, and it takes one more headache out of the process of getting to know a new piece of equipment, which, you know, any major piece is going to be a learning curve, and this is one thing that takes some of the heat off of them of learning a new system. This is also one of the more interesting bits, because I know tunnel inspection is kind of esoteric, and it certainly requires some different launch methods than maybe otherwise seen. There was a GPS system working off a base station on this vehicle, and I always say it's kind of funny. I like this, so it's a quick video. Why this guy needs to be running alongside of it, I don't know, but apparently he does. So I always find that kind of entertaining. But again, this still requires a high level of precision in where on that tunnel it is. Oops. So kind of wrapping everything up, the positioning is a major key component to all of our systems. It doesn't matter how good your GPR data is if your swaths look like a spaghetti line when you drill straight. Also, all of the data has to be geo-referenced. So we're doing that in 3 dimensions. We have to have the GPS data correct to match into the GPR data. We work with a wide range of customers, so each is going to require different levels of precision and different budgets. And the Spectra system has basically become our go-to because it does offer different types of solutions, and it really has been reviewed excellently by all of our customers. So when I do my customer follow-ups after a system gets installed, everyone is very complimentary. It just works. It's out of the box, and they don't have to think about it, which is exactly what you want, right? You just want it to work. And lastly, for working with Spectra and Duncan-Parnell, we live and die. You know, we're a high-end solution. We're the top of the market, and customer service, making sure that our people who just spent $250,000 with us, that they're up and running. We live and die on that. And Duncan-Parnell has become a really great partner that both sets it up correctly. If there is a problem, they're right on the phone, and they are our subject matter experts. And all of our customers that have worked with them have been more than happy about it. So that's it, my 2 cents. If you have any questions, just give me a go through, or otherwise, Russell, anything from you, sir?
Yeah, so I completely forgot to introduce myself. Sorry, but Kent did. I appreciate that. I was all excited about introducing Kent. But Kent, thank you for the introduction. So I am the technical sales rep for Virginia, Maryland, Delaware, at least Eastern Virginia, Maryland, Delaware, for Duncan-Parnell. Also on this call, we've got some other folks that work with Duncan-Parnell as sales representation from Florida all the way up here to Delaware. So it's really nice to have everyone here today. I see some other names on here, some folks, some customers, some just general people just really interested in learning about this. What I will point out, and if I can go ahead and share my screen, please. Thank you, Marissa. I wanted to go over a couple of the products. Kent had some really good, here, let me see here. Let me go ahead and, there we go. Kent had some great photos of our solutions in action, which I was really excited to see. One of the reasons why we're so keen on Spectra for this is specifically because of the ability to deliver an affordable solution at a really good price point that's cabled and that's rugged. One of the really neat things here, and I'm going to point out this SP60, you can cable this solution. And remember, the SP60 is the Spectra Precision 60. And that device, you can get it in anywhere from 1 meter down to centimeter accuracy. So this is just mounted on a simple pole, but with Kent's solution with 3D radar, you take it off a survey pole, stick it on a GPR device. on his 3D radar solution, and you're off and running doing high accuracy GPR work. And he touched on it, which is really great, is accuracy. You can have the best scan in the world, but if you can't get back to that issue area that you identified while scanning, it's pointless. So, having the SP60 on board with that equipment is a really easy solution. It's a plug and chug application. Once it's installed, once it's cabled up, and you're receiving positioning through the GPS device, the GNSS receiver, you're going to get that centimeter, 2 centimeter accuracy. So this is what the SP60 looks like. It's actually a fairly small piece of equipment considering you're getting the accuracy level that you're trying to achieve. These are pictures of actual, doing field mapping and survey type work. But I want to point out something here. Your accuracy is fantastic, but one thing that really helps here is you need a correction service, and something with having systems that are being sold to people that may not work just within a city. You may have to travel for work, meaning you may have to locate a different correction service that may not be in your city. It may be regional, it may be another state, it may be a different country. And this is where I'm going to point out something here. I'm going to scroll in. RTX corrections. RTX corrections are extremely important for those mobile field crews that need to be able to travel but don't have time to locate correction services where they go. And what the correction service does, it uses, in this case, RTX is a satellite-based correction service that give you the ability to get high accuracy without having to tie into an IP network. So you don't have to worry about having cell signal or having an IP connection. You can use satellite-based corrections wherever you go. That's really, really a time saver. It saves money too, because if you're traveling, all over the states or all over the world, you don't want to have to go find that stuff. It's really hard. There may be a language barrier. There could be a transformation issue between the correction service and your mapping solution, in this case SP60. So RTX is becoming a really, really popular solution for my customers. And I can say, the Trimble products and the Spectra products in large part use RTX, and it's taken off by leaps and bounds. People are driving themselves to this solution. They're finding it online. I'm talking with people, so very, very popular. And because of the RTX, I wanted to talk about that. So Trimble RTX is real-time extended corrections, and this is primarily what a lot of the customers using the GPR devices are using, because they don't have to worry about finding a correction service, which is really, really convenient. So RTX is real-time extended. There's a lot of great documentation out there. It works extremely well with the Spectra line of products, and pretty much you would mount the SP60 to your GPR device, and once it's cabled, the corrections are loaded directly or activated on that GPS device, on the GNSS receiver itself. So you don't have to have some post-processing workflow to do it. It's done by the time it's stored in your onboard system on the GPR or in your vehicle or even on your data collector. It could be a cell phone. That data is already corrected, so you don't have to worry about doing differential correction post-processing on the back end, which is a huge time saver. So if anybody's interested in this or any of the other technology, Kent's information is on here. I'll also share my information. We'll be doing a follow-up email, and we'll also be sending out a video link to this this webinar for everybody. If you couldn't make it, anybody that even registered but couldn't make it today, they'll still get a link to the webinar recording. So with that being said, I'd like to open it up to question and answer. We've got a little bit of time left, so if anybody wants to throw out some questions. I see one question did come in. Let me see here. That was from Nancy DeWitt. LOL. I love this communication. we're all using this these shortened abbreviations. So cabled up means exactly what you are connecting via cable between the Spectra SP60 and the GPR device. If you're doing just basic GPS data collection, GNSS data collection, mapping, you could be using Teraflex for data collection. You could be using, some Esri product. You could be using Mobile Mapper from Spectra is a fantastic solution. You can Bluetooth connect to the SP60 and get centimeter accuracy, in your hands while you're walking around. You don't need a base and rover configuration. So you can literally take the same device that you purchased for your GPR and take it off the GPR device and actually do data collection as well. If you need to return back to that position, you can use the same GNSS receiver to navigate right back to that area that was identified in the scan. Let me see here. So that's cabled up. Let me see here. Do we have any more questions out there? Well, with that being said, I'm going to go ahead and let's go ahead and wrap this up. I don't see any more questions.
Russell, we actually did have another question come through.
Oh, sorry, I missed that. Okay. Thank you. Let me see here. I'm trying to get back to my chat window. Okay. For the RTX subscriptions, is it yearly or can it be purchased months at a time? We have several different ways to do this. We can do it yearly, we can do it monthly, or we can do it, we actually do rentals. So if anybody's interested in any of these, feel free to reach out. RTX works with Spectra. It works also with our Trimble line of products. It works really well with the SP60. We find a lot of draw towards that. Just think again how much time having real-time correction services correcting your GPS or GNSS receiver's data before it ever makes it to your data collector to be stored. No more post-processing. That's just it's really a time saver, and time is labor. Labor is money. So that's the way we kind of look at it.
Hi, Russell, Joaquin here. I have a question for Kent.
Yes.
So Kent, if the customers use your services, say I'm talking right now a utility, they want to map their pipes, they want to install new pipes on the ground. So they hire you to provide the full service and you deliver that information, or you just provide the equipment and the customer ended up doing themselves? How that works with you guys?
We are just the manufacturer of the equipment. So we sell to basically anyone who, at the end of the day, the asset owners tend to be agencies. But half the agencies that we work with are do-it-yourselfers, so we sell it directly to them, and half just outsource everything. So we'll sell to the engineering firms that go out and provide those services to the agencies. So we just do the manufacturing, and we certainly help if someone has a job that needs to be done and they like our data specifically, then I'll put them in touch with one of our customers that kind of services that area and that application.
Got it. Okay, I see it. So you said it can be applied in totally different industries. It is not constrained to any specific. So based on the technology, you can identify almost any asset or all assets that are buried on the ground.
As a general rule, yes. What anytime you start talking GPR and physics, it becomes depends also, just to make sure. So certain soil types are not conducive to GPR. For instance, if you got high clay, if you're trying to look under metal, anything that is conductive will just diffuse what we try and shoot down, the electromagnetic signal. So, but as a general rule, transportation structures are pretty friendly. A lot of soils are perfect for it. So any kind of like sandy loam, you can get down really deep and see great things. So it just depends on what you're trying to shoot through. But yeah, anything you want to see below the subsurface, or even as the tunnel shows, you're shooting up into something, same idea.
Got it. Okay, thank you.
All right. So as Kent may have mentioned earlier, let me see. Am I still on? Did I lose it? Oh no.
You're there.
Oh, okay. Sorry. My screen way. I'm just going to keep talking. As Kent mentioned earlier, really the relationship is, Kent gets leads. People come to him. They're really interested in the 3D radar solution, and they also ask him, and he recommends us for the Spectra line of products that work really well. And also on this call too, I'll mention Joe Sass from Spectra is present. And we work at, we're Duncan-Parnell is a distributor. Joe works with the manufacturer Spectra. And so we've worked with Joe and Kent to make sure that any specs, any absolute requirements for his GPR systems that are required, we get those specs, and before the SP60 or whatever Spectra device goes out the door, it's configured before it leaves, which means it truly is a plug and chug operation. You could hook up his 3D radar solution to whatever vector of field work that it will be attached to, and you'll put the SP60 on top, you'll cable connect, go through a couple little startup procedures, and you're off and running in most cases. But we do a lot of where we've done a lot of work working with Spectra and getting the requirements and making sure that the Spectra GNSS receiver is set up with the baud rate, with all the specifics required for that GPR device in particular. So we found it saves us a lot of effort doing this first instead of doing a lot of head scratching and tech support after the fact. So this is what we've been pretty happy about being able to deliver, and we hope to keep Kent happy in the future, because he seems to like what we have to offer. So we're going to keep going that way, but it's always a unique situation for any customer. We work directly with the customers and Kent to make sure that everyone's on the same page. When the stuff's delivered, it gets delivered generally at the same time, and when it's ready to go online, we're all standing by to make sure that within a day we can generally get everything up and running. Okay. So that's all I got today. Kent, did you want to add anything else?
No, just my sincere thanks. Working with you guys and your products has really been phenomenal for us, because it keeps our customers happy, and it's the name of the game. So thank you very much.
All right. Well, thanks. We'll go ahead and wrap it up here. We're gonna close up the recording, and anyone that registered or attended will receive a link to the recording, as well as some contact information for myself, Kent, and the rest of the team over here at Duncan-Parnell. And if there are any questions afterwards, please reach out directly, let us know, and we'll do our best to get you the answers quickly and concisely. And between me and Kent, I'm sure we can get you everything you need.